Hi, welcome to the Seismic Retrofitters channel. Today we're performing some grouting work. I decided to make a video about this because in a lot of cases we find that grouting injection is needed in certain buildings, or I should say under certain buildings, and it's hard to explain to the customer or the client what exactly grouting is. I'm here with Steve and Rick with Geo Grout, and we're at a building on Laguna in San Francisco, and we're grouting underneath the old foundation, the old brick foundation. And I was just going to ask Rick a little bit about the process, about what we're doing in this particular case.
Well, right now what we're doing is just a little soil stabilization, going down the depth about 6 feet, every 2 foot on centers, all the way across the foundation, and help stabilize the structure. As far as liquefaction, there is done in this area, but we're just basically building piers.
Yeah, like columns of...
creating sandstone columns,
yeah,
underground.
So if you don't know anything about the grouting process, in this particular case, we're dealing with a loose sand. It's almost like a beach sand. And so what we're trying to do is stabilize the soil, because this building has been settling over the years. It's 100 years old and it's moved quite a bit. We haven't lasered it or checked it, but it's out. You can just, your eyeball can tell. And in this particular case, like I said, we're dealing with loose sand. So Steve, can you talk about like the different processes from the dry loose sand compared to like in the marina where it's like liquefaction?
Yeah, so we'll stabilize the sand again using the same technique, but what we want to do is keep the water from washing when it shakes, when there's an earthquake.
Right.
We don't want the sand to loosen up. So by injecting it, we create a solid mass of sand, like a sandstone, and that keeps the water from washing and creating voids under the foundation.
Right, so it could be used in a variety of different applications. It's really an amazing system. What it does is it can fill in voids, it can stabilize sand. It basically turns loose sand into almost like a sandstone-like product. And when you're in areas near the marina where it's liquefaction or wet soil, it'll displace that water and it'll solidify the material. So it's we've used it quite a bit with a lot of success, and it's money well spent. Like they say, an ounce of prevention. Just a side note, I know from the '89 earthquake that along the Marina Greens down here, one of the homes sunk 6 feet. They call that rapid settling. So something like this, if this was done underneath that particular home at that before the '89 earthquake, that would have mitigated the settling for sure. So it would have avoided a home sinking 6 feet. So it's definitely not a smoke and mirrors here. It's a real engineered process, and with some great results. In this particular case, like I said, we have a brick foundation. We're just trying to stabilize the foundation so we don't get any more settlement. Could you explain what is there differences between like what you're injecting here compared to like other jobs?
Well, in this one, in this area, this is sand, so this is what we use in all the areas,
right,
other than like a water shutoff. But we have stabilized over 4,000 buildings in the San Francisco Bay Area,
right,
which is quite a few, and we've had incredible success ratio, yeah, on those. But yeah.
And so the truck here, the equipment, you have that pump going, and now that it's like a high pressure system?
It's a low pressure, yeah.
Oh, so what kind of PSI are we talking about?
We're looking about 100,
Maximum PSI on that one is 300 PSI.
So you say low, at 300 sounds like
on the high.
Pretty decent. And do you do any high pressure stuff?
Yeah, absolutely. That would be compaction grouting, yeah. That's a whole different technique.
Okay, that's a different technique.
For clay soils.
And what kind of PSI are you talking about there?
Now we're looking maybe 1,200, 400 on the actual nozzle.
Okay.
But the pump could put up to about 1,800.
Wow, okay. And then what would that be applicable for, like the compaction grouting?
We're trying to grout the soil under compaction. What we do is we create columns, same thing, create columns every 5 foot on center, approximately.
Yeah.
And we force the soil in against one another. It compacts the soil against one another.
I see.
Different application.
Yes.
It's a mortar grout that we're injecting into the ground under 400 or 500 PSI, and it's used for liquefiable soils in the Marina District.
Okay.
I did over 85 homes in the Marina District with just injecting
So
soil
if
into
you were
soil.
to do a cutaway and look at the side, like for the soil, it would look like big columns, and it's
Exactly,
pressurizing
yes.
the soil in between, so it creates this high pressure scenario.
That's correct.
Oh, that's really neat.
But we would do that on a grid basis, so it'd be a 5x5 or a 4x4 grid basis, or a diamond shape.
Right.
So the grid would force the soil in, column against each other, column per column against each other.
Okay, got it. I've heard there's some concerns that potentially the buildings can actually be raised a little bit. Have you ever had that happen?
We can control the lift, and we use monitors to monitor the foundation. So when we lift it, we can either level out an existing building that was off, bring it back up close to level.
But in this particular case, it wouldn't work because you have a narrow perimeter foundation, I'm thinking?
No, that's fine. We can do that too. Again, we raise the soil, we can again monitor it.
Right.
So we can raise the soil and lift the building without damaging the structure.
Oh, interesting.
Yeah.
So that's something, that's a process that you're actually monitoring as it's happening?
Yes. Yeah.
Okay, and you have some kind of equipment set up?
Yeah.
So in that particular case, if we have a building that's settled, rather than do potentially a foundation replacement, we can come and have you guys come in and do that, and potentially do for lack of a better term, some repairs.
Yes.
Okay, well that's very interesting. Well, I really appreciate the time here, and that's it for now, but that's over and out.